Welcome to the deep dive. Today we're getting into something called meta-analysis.
Yeah, a really key tool in research.
Absolutely. You shared some great material explaining it, and well, our mission today is to unpack what that means and why it gets called, the gold standard.
Sounds good.
So let's just dive right in. What exactly is a meta-analysis? Is it just like a big literature review?
Uh, Not quite. It's more than just summarizing. It's actually a quantitative way to combine results from different studies.
Quantitative. Okay.
Yeah, using statistics to synthesize the findings from multiple studies looking at the same or very similar questions. Think of it like a statistical pooling of results.
A super study, almost.
Exactly.
Yeah.
That's a great way to put it. A study of studies.
Okay, I like that. So why the gold standard label then? What makes it so highly regarded in, say, evidence-based practice?
Well, a big part of it is statistical power. By combining samples from many studies, you get a much larger overall sample size.
Ah, so you're more likely to detect an effect if it's actually there, even a small one.
Precisely. And also, you know how sometimes studies seem to contradict each other?
Yeah, that can be really confusing.
Right. So meta-analysis can help resolve those conflicts by weighing all the evidence together and giving us a more stable overall estimate of the effect.
Okay, so it increases power and helps make sense of conflicting findings. Makes sense. Now, something called effect sizes came up a lot. What role do they play?
Effect sizes are crucial. They basically measure the magnitude or strength of the finding in each individual study.
So not just if something happened, but how much.
Exactly. Is it a big effect, a tiny one? Meta-analysis averages these effect sizes, often weighting them by study quality or size, to get an overall picture of the effect's magnitude across all the included research.
Got it. And if someone wanted to actually do one of these, what are the basic steps? It sounds pretty involved.
It definitely is thorough. Generally, you start with a very clear, focused research question.
Okay.
Then you do a really comprehensive search for all relevant studies, published and unpublished, ideally.
Right. Got to find everything.
Then you assess the quality of each study you found, because you don't want bad studies skewing the results.
Makes sense. Garbage in, garbage out.
Exactly. Then you extract the key data, especially those effect sizes,
Mm-hmm.
and then you perform the statistical analysis to combine those effect sizes. Finally, you interpret the overall result and, importantly, look at the variability between studies.
Okay, that sounds like a solid process.
Yeah.
But you mentioned variability. Are there limitations or criticisms we should know about?
Oh, definitely. One big one is heterogeneity. That's just a fancy word for the studies being different from each other.
How so? Different methods, different populations.
Yeah, exactly. Different ways of measuring things, slightly different groups of people. Trying to average results from very dissimilar studies can be, well, problematic. Like averaging apples and oranges.
Right. And I remember reading about something called publication bias. How does that fit in?
Ah, yes. Publication bias is a real challenge. It's the tendency for studies with statistically significant results, the ones that find something interesting, to be more likely to get published than studies with null results, where maybe nothing much happened.
So the published literature might look more positive or exciting than the full body of research.
Exactly. And if a meta-analysis only includes published studies, its results could be skewed, potentially overestimating an effect. Researchers have ways to try and detect and adjust for this, but it's tricky.
Okay. And quickly, there was mention of fixed effects versus random effects models. What's the key difference?
So basically, a fixed effect model assumes there's one single true effect size that all the studies are trying to estimate. Any differences between studies are just seen as random error.
Okay, one true effect.
Whereas a random effects model assumes the true effect might actually vary from study to study. It allows for that underlying heterogeneity we talked about.
So it assumes the effect of, say, a therapy might genuinely be a bit different in different contexts.
Precisely. The choice depends on assumptions about the studies being combined. Random effects is often more realistic when studies aren't identical clones.
Interesting distinction. How does doing all this, combining studies this way, help us build better theories in fields like psychology?
Well, by providing a more precise and robust estimate of an effect, it gives stronger evidence for or against a theory. It can also identify patterns, like, does an intervention work better for certain groups? That points researchers towards why, refining the theory.
It helps find moderators, basically, factors that change the effect.
Exactly. And spotting inconsistencies can also spark new research questions.
Are there specific tools researchers lean on for this, like checklists or ways to show the data?
Yeah, definitely. The PRISMA guidelines are really important. They help ensure systematic reviews and meta-analyses are reported clearly and thoroughly.
Okay, Prisma.
And visually, you'll often see forest plots. These show the effect size from each individual study and the overall combined effect, all in one picture. It really helps you see the pattern and the consistency, or lack thereof.
Forest plots, right. And finally, stepping outside of academia, how might someone like a clinician or maybe a policymaker actually use these findings?
Well, meta-analyses often represent the highest level of evidence on a topic. So a doctor could use a meta-analysis on treatments to inform their clinical decisions, choosing what's shown to be most effective overall.
Based on a synthesis of many studies.
Right. And policymakers might look at meta-analyses to guide public health strategies or educational programs, investing in things with solid, combined evidence behind them.
So, wrapping this up then, for you listening, meta-analysis is clearly this really potent method for synthesizing research, aiming for more reliable conclusions than single studies alone.
Definitely powerful, yeah. But not without its challenges, like heterogeneity and publication bias.
Right, complexities to be aware of. But understanding the core idea helps you critically evaluate the research you come across, which kind of leads to a final thought. How might understanding this study of studies approach change how you look at information or evidence in your own field, or even just in daily life? Something to think about.